Now, the next part is going to be for us to establish a point, a specific point on this area. Let's start by working on this. And again, introducing another very frequently used operator from Houdini, which is scatter. Scatter allows us to scatter points on surfaces or on volumes. It is a very powerful operator that we'll learn about throughout the course. Right now, what we're going to be doing is we want to scatter points on the chest. We actually just want to scatter one. This is the main thunderbolt, so it's just the main beam of lightning that's hitting the surface, and we just want one area, one specific target. And here on the scatter, we can force a total count, and in this case I want to force a total count of 1. So that way we have 1 point on that surface. If we template the surface, you'll see that it's not changing. It's scattered on that surface and it's going to keep exactly on the same point. That's not really what we want. We want the lightning to kind of jump all over the place. So what we can do is, when you apply a scatter, let me increase the points to 10, for instance. Or maybe let's put it at 1,000. Right now, the scatter is working at its default settings, and the default settings give us this type of uniform scattering of the points. They're kind of relaxed in terms of in their relative position to one another. And that's because the relax iterations are active. If we disable the relax iterations, you'll see that the randomness is much more clear. So they're really randomly distributed on the surface. Some of them are really close together, some are further apart. So this is going to be a better way for us to visualize my point. You also have a global seed, and this global seed is the number that's going to be used to generate this random distribution. If you change the global seed to 1, for instance, you'll have a different random distribution, and so on and so forth. We can use this global seed to make sure that our point changes its position on the surface on every frame. All we need to do is, here on the global seed, we can, for instance, use the global variable that we're already familiar with, which is $f, which refers to frame. And that way, on every frame, we'll have a different seed, and a different seed is always going to be generating a different point. Let me turn on the point. Okay, and it's jumping all over the place. When the geometry changes to the arm after frame 24, it's going to keep doing the same thing. So the surface where it's scattering, it's different. It's still going to be scattering just 1 point on that surface, and it's still going to be changing and jumping all over the place. So that point represents the target to which the thunderbolt is going to be connecting on Iron Man. Now we'll do the same thing for the source of the lightning, which will be the hammer. So we can just use Alt, click and drag. And this time I'm going to just disable the template here. Connect it there, enable the template here. And let's have a look at this. I'm going to hit F to zoom in. Make sure we have the surface visible. Okay. And as you can see, we'll have the source of the lightning. The point that's going to be the source of the lightning is always going to be jumping around as well. If you think it's jumping around too fast, let's say, yeah, it's just too much. Changing from every frame, it's a bit too much. What we can do here on the global seed is, instead of using just this expression where we'll have on every frame we'll have a different global seed and it's going to keep jumping around, we can use a very simple expression to keep this position for a certain amount of frames, let's say 3 frames. What we'll do is, here on the global seed, we can say floor of $frame of the frame divided by 3. This number 3 will represent the number of frames at which the global seed is going to be the same. What this expression represents is that when you divide a whole number by 3, let's say we're dividing 1 by 3, we're going to get 0.33333. And the floor expression is going to round that decimal number into its lowest integer number. So what we're going to be getting from this expression, let's click here, 0.333 rounded down, it's going to give us 0. At frame 2, we'll have we're going to be dividing 2 by 3. It's going to give us 0.66666. So rounded down, it's going to give us 0. At 3, it's going to give us 1 because 3 divided by 3, it's going to give us 1. Rounded down, it's still going to give us 1. And as you can see, this way we can hold the same global seed every 3 frames. So it's not jumping around as frenetically as it was before. And this will probably give us a nicer result. It's not as irregular. So let's use the same expression on the chest area, on the chest, the scatter of the chest. I'm going to hit F, the same seed. Same thing. Let me just make sure we template the geometry. Hit F so we can see it. And we should have exactly the same effect. So every 3 frames, if you put, let's say, if you divide by 9, for instance, it's going to hold every 9 frames, it changes. Okay, but let's keep it at 3. Let's see, let's go to camera 2. And with this, we have the 2 points. We have a source, our source and our target, and we're good to go.